All right, so chapter 4, section 1 and section 2 are using information to graph rational functions and with their asymptotes. So these are all rational functions being ones that have variables in the denominator. So this is going to have an x in the denominator. It could have a whole expression in your denominator, but that's what makes these graphs unique. When you put that variable in the denominator, it restricts your domain, because remember, if you think about if there's a variable in the denominator, we say whatever that would equal 0 can't be a value, right? So it restricts our domain. And on a graph, it shows up as what's called an asymptote, which is the line that's just like a dotted line. It actually doesn't show up on a graphing utility. You would draw it in, okay? But you'll see it start to affect your graph. So they could look something like this. So this is just your like parent function of 1 over x. There's a vertical asymptote. Here, you don't see it again, but it does affect your graph because as those lines, so these are my curves, as these curves approach that line, it can't touch it, so it turns and it increases to positive infinity or it decreases to negative infinity. So that's what that asymptote does. It's like a stop and turn at this point, and you're getting as close to that line as you possibly can without touching it. So all this notation over here is just like, it's weird, it looks weird, but it's the limit of f of x as it's approaching infinity. So that f of x, which is the y coordinate, is approaching infinity or positive infinity as x moves towards 0 from the positive side, so from the right. So as I come closer to that asymptote, it turns and it goes up and it keeps increasing, it never stops. In the other direction, this one says f of x is approaching negative infinity because it's going down at this point and it's going to keep decreasing as it approaches 0 from the left, which is what that minus means. You'll never actually have to write out that notation. It's just that when you see it, don't be alarmed. That's what it means, okay? And then there's also a horizontal asymptote here at 0, and that's what's happening in the bottom here. So if you read on the bottom, now it's saying f of x, which is the y value, is equal to 0 as x approaches infinity. So as x goes to infinity, this should actually be approaches. This is arrow. F of x is going closer to 0. And as x is increasing or going to negative infinity, which is now the left direction, this is also approaching 0. So they're both going towards 0 but never touching 0. Again, you'll never be tested on this notation, but this is what limit notation looks like. So like when you hear people in calc talk about limits, this is what where this comes from. It's approaching those things, but it's never touching it, okay? So the further left we move, the closer my graph gets to 0. The further right we move, the closer my x gets to, or the y gets to 0, but it's never actually going to touch it. All right, so there are 3 types of asymptotes we're going to find. The first is the vertical asymptote. So this is obviously a vertical line. It's going to be an x equals equation because it has to be a vertical line. And the way we find it is by just setting the denominator equal to 0. So whatever's in the bottom, we set equal to 0, and we solve for x, and that is where our asymptotes are going to occur. There can be more than one vertical asymptote. Okay, there could be, usually there's at least one in this kind of, there's exceptions, but usually there's at least one. But there can be 2, there can be 3. Okay, there's no limit to how many vertical asymptotes there are. And again, we find them by setting the denominator equal to 0. The horizontal asymptote, and for these, there can be 0 or 1 of these. Oh, sorry, I didn't say this, but a graph cannot cross a vertical asymptote. So if you've got a vertical line, that's your asymptote, you cannot touch it. The horizontal asymptote is usually, it doesn't touch it, but there are exceptions and it can cross it. You'll see that today, what happens when it looks like when it crosses it, okay? But it is determined by the relationship of the highest exponent in the numerator and the highest exponent in the denominator. So n is what we call the degree of the numerator, which would be the highest exponent in the numerator, so in the top of my fraction. And then m is the degree of the denominator, which is the highest exponent in the bottom of my fraction, so in the denominator. If the number, the highest exponent in the top is less than the highest exponent in the bottom, so if n is less than m, then my horizontal asymptote is at y equals 0. If n is greater than m, so if the highest exponent in the top is more than the one in the bottom, then there is no horizontal asymptote. And if they are equal, if the highest exponent in the top is the same as the highest exponent in the bottom, then the asymptote is at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So leading coefficient meaning the number on the front of the x that has the highest exponent. So those are your three scenarios with a horizontal asymptote. They are either the one in the top is less than, so it's 0, they're equal, so it's the leading coefficients, or the one in the top is more than, and there's no horizontal asymptote. If the n, so the one in the top, is 1 more than m, or the one in the bottom, then there's a slant asymptote. So if n is 1 more than m, then there's a slant asymptote, which is just a line that has some sort of slope. Whether it's positive slope or negative slope doesn't matter, but it's got some sort of slope, so it's got like a diagonal line. And the way you find the equation of that line is dividing the numerator by the denominator and ignoring the remainder. And you'll get like a, 2x plus 1 or x minus 3, something like that. And you just set y equal to that, and that is your line. That is your slant asymptote. So the first things we're going to do with these are just find them. And that's what your quiz is going to look like. It's going to say find the vertical asymptotes, find the horizontal asymptotes, find the slant asymptote. And then you're going to put it all together at the end, and you're going to graph it. And that's where your graphing utility becomes your best friend. The last thing is a hole. So a hole occurs on your graph if you can simplify the function by crossing through a factor in the numerator and the denominator. So the very first thing we're going to do with our, let's say our functions, are factor them. If it said x plus 1 in my numerator, and in my denominator I ended up factoring and I got x plus 1 and x minus 1, and I cancel through one of the factors of my denominator, I just created a hole. So I got rid of a vertical asymptote and I created a hole. So if you can simplify, so it's the very first thing we're going to check every time, is can we simplify? And if we can, by canceling something from the bottom, we just eliminated a vertical asymptote, but we turned it into a hole because that value is still undefined. And so in this case, to find the hole, it's going to be a coordinate point, so it's going to be an xy. We find what value of x would have been the solution to the one we crossed out. So if I said x plus 1 equal to 0, x would have equaled negative 1, and that's the x coordinate of my vertex. And then I find the y by plugging it into the simplified version of my function. So this now becomes 1 over x minus 1. And I would plug in the negative 1. And my y would be negative 1/2. And then we'll talk about again what that looks like on your graph. What you won't see is if you type this equation into your graphing utility, it will show you the simplified version of your function. It will automatically cancel those through, but you won't see a hole. So you have to be smarter than your graphing utility when there's a hole involved. All right, so all we're going to do from here on out is practice all that stuff. That is basically everything that is on your quiz. Now we just got to figure out how to use it. All right, so we start with the asymptotes. This says find the horizontal, vertical, and or slant asymptote. At most, it can have two of these because you can't have a horizontal and a slant. It's one or the other. It could be neither, but it's one or the other. So we're going to start, I always start with vertical. So I know like this, the instructions say horizontal, but I always start with the vertical. So the vertical, we set the denominator equal to 0. That's how we find it. Before we do that, we're going to check for holes though, because that impacts all of it. So if I look at number 1, can I factor the numerator or the denominator? No. Can I cancel anything out? No. Yeah.
What did you say?
The denominator for vertical asymptote. So this can't be simplified. That was our check for holes. No holes. Okay. But now for the vertical asymptote, we're going to take the denominator and we're going to set it equal to 0 and solve for x. So our vertical asymptote is at x equals 1. Which will be a question on your quiz. Then we check for a horizontal asymptote. What's the highest exponent in my numerator? What would be an exponent on the x? Is there an x? No. So what would be that exponent? If it doesn't exist. 0. So this would actually have an x to the 0 power if there's nothing there. So the highest exponent in the top is 0. The highest exponent in the bottom is what? So the 0 is my n, the 1 is my m. If the number in the top is smaller than the one in the bottom, what's true about my horizontal asymptote? We'll write it out so it's on here. Horizontal, there's 3 scenarios, right? If n is greater than m, there's no horizontal asymptote. If n is equal to m, then I do the leading coefficients. And if n is less than m, y is equal to 0. Those are the 3 scenarios. So because the numerator is less than the denominator, I have a horizontal asymptote at y equals 0. And you can't have a horizontal and a slant because in order to have a slant, the one in the top has to be 1 more than the one in the bottom. So there is no slant. Yep.
What does the movement say?
Horizontal asymptote? Or you mean at the top?
At the top.
Y equals the LC for leading coefficient. Yeah. You'll see it. That's in the second one. Okay, again, remember slant asymptote, n is 1 more than n. All right, we go to 2. Can I factor the numerator or the denominator? No, can't cancel anything out, which means there's no holes. So now I go vertical asymptote. Vertical asymptote, I set my denominator equal to 0. I get 3x would equal -2, and x would equal -2/3. So that's my vertical asymptote. Questions so far? Okay, now I go horizontal asymptote. What's the highest exponent in my numerator? 1. What's the highest exponent in my denominator? 1. So what's true about those? They're equal, which means I do y equals the leading coefficient in my numerator, which means the number on the front of that variable that has the highest exponent. In this case, it's 2, good, over the leading coefficient from the denominator, which is 3. So my horizontal asymptote is y equals 2/3. And is there a slant asymptote? No. Highest exponent in the top has to be one more than the bottom. Can I factor the numerator or the denominator? Can you factor x squared plus 1? No, right? If it was minus 1, we could factor it, but plus 1 we cannot. So there's no holes here. I didn't cancel anything out. So now I go vertical asymptote. Vertical asymptote, I set the denominator equal to 0, and I get x equals -2. Then I go horizontal asymptote. What's the highest exponent in my numerator? 2. What's the highest exponent in my denominator? 1. So what's the relationship there? Top is bigger than the bottom, which means there is no horizontal asymptote. And it's one more, which means this time we have a slant. Good. So we find the slant by dividing. So I'm going to take my numerator. You can divide using long division or you can divide using synthetic. Obviously, I'd recommend synthetic. Looking at my numerator, are they in order decreasing degree, and is there a term there for all of them? This time I'm missing what? I'm missing my x term, right? So it would be 0x. So if I wanted to do it long division, it would be x squared plus 0x plus 1 divided by x plus 2, and I would divide it. Or I use synthetic, it would be 1, 0, 1. What goes on the outside? -2, good. It follows the x, so I got to change the sign.
What did that say under what is that? Plus 0 or
I'm missing the x, so I would add in a 0x. So now I bring down the first term, I multiply by -2, put it in the second column, add it, I get -2. Now I can keep going, but I am totally going to disregard the remainder on slant, so you can stop there. Just realize whatever is there, that would have been my remainder. So the -2 stays as it is. The 1 gets the x. And then I set it equal to y. So y would equal x minus 2, and that's my slant asymptote. So to find a slant, I divide the numerator by the denominator, ignore your remainder, set it equal to y, and that's the equation of your line. That would be a slant asymptote. Questions so far? Okay, let's keep going. All of these numbers should be different. We're just going to go with it. So this technically should be 4. Okay, it says the same thing. Find the asymptotes and check for holes. So if I look at the first one, can I factor either the numerator or the denominator? Nope, nothing's going to cancel, which means no holes. To find my vertical asymptote, I'm going to set my denominator equal to 0. Can I factor this? How would I solve it if I can't factor? There's actually 2 answers to that. Because there's not an x squared and an x, I can use the even root here. I can subtract the 1. 3x squared would equal -1. Divide both sides by 3. X squared equals -1/3, and then square root it. What happens when I try to square root a -1/3? There's no solution, right? So there is no vertical asymptote this time. Then I go horizontal asymptote. What's the highest exponent in my numerator? 1. Highest exponent in the denominator. What's that relationship? 1 in the top is less than 1 in the bottom, right? Which means what? y equals 0. Is there a slant? No. Can there be a slant and a horizontal? No. Okay, there could be neither, but there can only be one of those two. And again, it would be if the highest exponent in the top is one more than the one in the bottom. All right, go to 2. Can I factor the numerator or the denominator? Yes. The denominator this time is the difference of 2 squares. So this becomes x plus 1 and x minus 1. So this is gone. Can I simplify by crossing anything out? No. So there's still no holes. To get my vertical asymptote, I'm going to set my denominator equal to 0. If I had done it from the beginning, I still would have factored and solved. So even though we factor at that step, it saves us the time here, because I would get x plus 1 equals 0 and x minus 1 equals 0. So x equals -1 and x equals +1. So there are 2 vertical asymptotes this time. Then I go horizontal asymptotes. To do that, I want to look back at my original exponents here because I crossed through it. What would have been the highest exponent in my numerator? 2, highest exponent in the denominator. 2, which means this is a leading coefficient scenario. Y equals the leading coefficient on the top, which is 2, over the leading coefficient on the bottom, which would technically be a 1. So y equals 2 is my horizontal asymptote. Is there a slant? Nope. Yep. For the equation, you look at, so to figure out the relationship, you use the exponent. To get the equation, you use the coefficient. Yep. Questions so far? All right, so I'm going to pause here and we're going to start to talk about what does this look like on a graph. And then we're going to continue on, okay? So when you have a graph of a rational expression or a rational function like these, you would plot your vertical asymptotes, you would plot your horizontal asymptotes, and then you can do this without a calculator. You can plot some points to find what happens in between. But you will have the opportunity to use your calculator. So like when you do this in pre-calc, we do this without a calculator. You figure out the points, you plot them, and you figure that out. For right now, we're kind of baby stepping ourselves into that direction. So the first thing I would do here is I would draw my vertical asymptotes. They are vertical lines that pass through, in this case, -1 and +1. So my vertical asymptotes are dashed lines because they're not real graphs. They're just guides for the rest of the graph. And then I would plot my horizontal asymptote, which is at y equals 2. It's going to be a horizontal line. And then what happens in between these changes? Sometimes it goes in the corners, like a top left, bottom right curve. Sometimes the middle shape looks like a parabola. Sometimes it looks like a cubic function. So they happen in all these weird ways. But one of the things that we use to figure out what it looks like in between without having a graphing utility is finding the zeros of my function. So if I want to find the zeros, which would act as x-intercepts, I set my numerator equal to 0. So if I set 2x squared equal to 0 and I solve for x, I end up with x squared equals 0 and x equals, it would be plus or minus 0, but that's still just 0, which means my graph is going to pass through the origin on here. It also means, because it'd be plus and minus 0, that there would be 2 zeros there, which the multiplicity is 2, which means it bounces at that point. So without a graphing utility, just knowing that information, I already know that that middle has to bounce off that 0, and it's going to look like a parabola shaped. The good news is you don't need to know that yet, because your graphing utility will show you that, okay? And then what normally happens with these, there are exceptions, but what normally happens with these is that on the outsides, they go in the opposite direction. So the curves happen here and here. Now we're going to graph it on our graphing utility. So there's like in between, like, there's a bunch of questions on your quiz, obviously, but most of the questions are just like find the vertical asymptote, find the horizontal asymptote, find the slant asymptote, that kind of stuff. And then there's going to be one that says graph it. So you're going to put it all together, okay, which is what we're working towards. Okay, so we are going to graph this on the graphing calculator. I'm going to go to my y equals, because that's where I graph from. And I have to type in that equation, that 2x squared divided by x squared minus 1. You have to use parentheses when you have more than one term in the numerator or the denominator, so be careful here. The 2x squared can just get typed in as is because there's not another term. But if it said 2x squared like plus 1, I would have to put that in parentheses. And then I've got, make that bigger, divided by, or you can use the fraction, which is under the math tool. Open your parentheses, x squared minus 1. You don't have to close your parentheses at the end, but you can. It doesn't matter. And then I'm going to hit graph. Oh, I'm zoomed out. Hang on, let me zoom it in. So notice on this graph, hang on 2 seconds. Notice on this graph, you don't actually see your asymptotes, right? There's no lines, but there is that same shape that we just drew. There's a parabola pointing down in the middle, bouncing off of 0, 0, and there's those two curves in the top. So the good thing is these don't have to be exact. Your asymptotes have to be exact. When you go to graph this, it's going to ask you for the zeros. Those have to be exact. Your y-intercept has to be exact, but your overall curves are an approximation of those curves. All right, let's go to 3. So what's the first thing we're going to do on 3 that we haven't had to do yet? Can you factor the numerator and the denominator this time? Yep. So in the numerator, I'm looking for the factors of -2 that sum to +1, which would be +2, -1. In the denominator, I'm looking for the factors of -6 that sum to -1. So -3, +2. Can I cancel something out this time? Yep, the x plus 2's can cancel. And what that does is it just changed my asymptote at x equals -2 just became a hole. So there's a hole at whatever value of x I would have gotten had I kept it, right? So if this is equal to 0, x would equal -2. So that is the x coordinate of the hole. Now, in order, yep. You're going to see it on the graph. There's actually a hole at that point. We're going to graph it. Yep. So then to find the y, I have to use my updated equation. So my f of x now equals x minus 1 over x minus 3. And that's where I would plug in the -2. So -2 minus 1 over -2 minus 3, which is -3 over -5, or 3/5. That means on my graph, there is literally a hole in the line at that point, or in the curve at that point. Yep.
I'm so sorry. How'd you get 3/5?
I plug the -2 into the updated function. So after I cross this out, this is what's left, x minus 1 over x minus 3, and you plug the -2 into the x. You're welcome. Okay, so now let's go back through. Everything we answer after this is based on my updated function. So when I look for my vertical asymptote, I use this guy. So my vertical asymptote is just x equals 3, no longer at x equals -2 and x equals 3. So instead of there being an asymptote, there's a hole there. What's the highest exponent in the numerator of my updated function? 1. And the denominator? 1. So this is the leading coefficient, horizontal asymptote. Leading coefficient in the top would be 1. leading coefficient in the bottom would be 1. So 1 over 1 is just 1. Is there a slant asymptote? No. Can't be horizontal and slant, and in order for slant, it has to be one more in the numerator than the denominator. All right, so let's graph what we know already. X equals 3 is our vertical asymptote. Y equals 1 is our horizontal asymptote. So now these graphs, when they only have like one of each, can go corner to corner. They could be top right corner, bottom left corner, or top left, bottom right. So something that would help me is by looking at my numerator. If I set this equal to 0, I end up with x equals 1 as my, so that would be my x-intercept or my 0. So if x is 1, that means it actually passes through here. And then the other thing I know is there's a hole at -2 3/5. So at -2 3/5, which would be about here, there's a hole. So the curve is actually going to come up to that spot and continue on after that spot, but you would have a hole at that point. Yep. The yellow one, the x-intercept, I set my numerator equal to 0. So whatever's in the top, if I set it equal to 0, that's going to give you a 0 or a solution or a root or whatever, but it shows up as an x-intercept on your graph. So I plugged in 0 and I got 1. So my coordinate point was 1, 0. Yep. Wait, just kidding. Did I plot that wrong? That should be at 1, not 2. I plotted it at 2. Hang on, sorry. That should be... Keep going. There we go. X would equal 1. So my x-intercept should be at 1. I plotted it at 2. I still have a 0 or a hole at -2 3/5. So there's still a hole there. But that curve, again, is going to pass up and not go, it's not going to pass through that hole because it's going to have an actual hole at that point. And then normally we go corner to corner with these. So I would know it happens there. But again, I'm going to use my graphing utility to verify that. Now what we won't see on the graphing utility is the hole. So I type in my updated function, and actually it doesn't matter. You could type in the original or the updated one. So I typed in my updated x minus 1 over x minus 3, and I had to group them both. So there's a parentheses around the numerator and the denominator. You have to group them. Otherwise, order of operations messes that up.
I have no idea how to graph it.
Okay, hang on 2 seconds. If I wanted to type in, and then I hit graph, and I get my actual graph. And notice that there is no hole. You don't see that hole. You have to be smarter than your graphing utility at this point and know that there would be a hole there, okay? And the same thing would happen if I typed in my original because it would simplify it for me. But I should end up with that graph. All right, how many of you did first and last to factor the numerator? Okay, so if I do first times last, I get -18. Factors of -18, that sum to 7, +9, -2. Put those in place of your middle term. And then factor by grouping. So I can take out a 3x and I get x plus 3. I can take out a -2 and I get x plus 3. X plus 3 and then 3x minus 2. So that's your numerator. X plus 3, 3x minus 2. And then my denominator, it would be x plus 1 and x plus 3. So what cancels this time? X plus 3, which means there's going to be a hole there. So there's a hole where that equals 0. So there's a hole at -3. If I set x plus 3 equal to 0, then I'd get a hole there at -3. So then moving forward, I'm working with 3x minus 2 over x plus 1. To find the y coordinate of the hole, I'm going to plug -3 into that updated equation. So 3 times -3 minus 2 over -3 plus 1, -9 minus 2 over -2, -11 over -2, which was 11 halves, or 5 1/2. Because I'm going to have to graph it, I made it a mixed number. Then to find my vertical asymptote, I set my new equation. So whatever's in the bottom, set it equal to 0, and I get x equals -1. The horizontal asymptote comes from highest exponent in the top and the bottom being the same. So this is leading coefficient. It would be 3 over 1, which is 3. And no slant asymptote. Yep. Vertical asymptote, you set the denominator equal to 0. But the updated one, so after we canceled it out. So now if I went to go graph what I already know, x equals -1 is my vertical asymptote. Y equals 3 is my horizontal asymptote. If I set my numerator equal to 0 to find the x-intercept, I'd end up with x equals 2/3. So I know it crosses through the x-axis at 2/3. And I know there's a hole at -3. So this was -1, -2, -3, and 5 1/2. So there's a hole all the way up there. So already I know that curve has to go up to that hole. So it's going to be up here. And then it's going to come down and curve before it hits that horizontal asymptote. And in the bottom right, it has to cross the x-axis at 2/3. So I know it's going to pass through something like that. And if I were to graph it on my graphing utility, and again, you can do it from the beginning before you simplify it, or you could do it after you simplify it. Your calculator will know to simplify it. I would get 3x minus 2 divided by x plus 1. And there's what my graphing utility shows me, which is similar to what we got. Again, it just won't have the hole. All right, we won't get through all of these, but we're going to do some of them. We won't graph them all either because we know how to do it. Like I would say for homework, you're going to see it. It's going to say find the vertical asymptote, the horizontal asymptote, the slant asymptote, all those parts, and then it's going to say graph, and it's going to give you a multiple choice. So use your graphing utility to figure out which one it is, but make sure that you can find all those other things without your graphing utility. All right, so I'm going to look at 5. Can I factor the top or the bottom? Nope. So I'm going to start by finding my vertical asymptote, set the denominator equal to 0. So 3 plus 2x equals 0, 2x equals -3, and x would equal -3 halves. Vertical asymptote comes from the denominator. Horizontal asymptote, what's the highest exponent in the numerator? 1, highest exponent in the denominator? 1, so they're the same, which is the leading coefficient. So leading coefficient of my numerator is a -7. Leading coefficient of the denominator is a +2. So the order here doesn't matter that it's switched. You're always grabbing the one that's attached to the variable. Because there's a horizontal, there is no slant asymptote, and also because the exponent in the top is not one more than the bottom. So horizontal, vertical, no slant. My zeros or my x-intercepts are going to come from my numerator, and eventually we're even going to find our y-intercept. We would do that by plugging in 0. Go to 6. Can I factor? Yep, denominator becomes x plus 3x minus 3. And I can cancel. The x plus 3's cancel. So there is a hole. where x would be -3. My updated is 1 over x minus 3. So to find the y coordinate of the whole, I plug in the -3. 1 over -3 minus 3, which would be 1 over -6. So there's a hole at -3 and -1/6. Yep. Whatever I cancel through, if I set that equal to 0, that's where the x coordinate of the whole is. Vertical asymptote comes from my updated denominator, so x would equal 3. Horizontal asymptote, I also look at the updated. There's no x in my numerator, so it would be x to the 0. And in the bottom, it's x to the 1st. If the top is less than the bottom, the horizontal asymptote is at y equals 0 and no slant asymptote. All right, 7, I can factor again, x plus 2, x minus 2, and in the denominator, x minus 2 and x minus 1. So the x minus 2 cancels, which means there's a hole where x equals 2. My updated equation is x plus 2 over x minus 1. I would plug in the 2. And my hole is at 2, 4. Vertical asymptote comes from the bottom. Set that equal to 0, and I get x equals 1. Horizontal asymptote, the exponent in the top and the bottom are the same. They are both 1s. So it's the leading coefficients, which would be 1 over 1 or 1. And there is no slant asymptote. Because one, you can't have a horizontal and a slant. But the real check is the numerator's exponent has to be 1 more than the denominator's exponent. So these are both the same. They're both x to the 1st. So if it was x to the 2nd and x to the 1st, now there's a slant. All right, last one. I can factor my numerator, x plus 2, x minus 1. The denominator, 2x and x plus 2 plus 1. And again, I can cancel. So there's a hole at -2. If I plug that in, I end up with 1 as the y. Yep. I go to my updated one for the vertical asymptote. I set that equal to 0. So -1/2, x equals -1/2. The horizontal asymptote, they are the same again. So it's the leading coefficients, which this time is 1 over 2. And there is no slant asymptote. All right, so again, tonight's homework is going to take you through, most of the questions are going to give you multiple parts. It's going to ask you for the vertical asymptotes, the horizontal asymptotes, if there's a slant, just like we kind of did, and then it's going to give you multiple choice on the graphing so that you can pick it. Make sure if you don't have your graphing utility with you today that you have it with you tomorrow. You don't want you don't want the calculator to be the reason why you struggle on the quiz on Wednesday. Because you can do it without, like we can plug in those points to see what our curves look like, but it's obviously going to be easier and save you a lot of time to use the graphing utility. And you want to get comfortable with it. Questions? So tomorrow we're going to add in like the x-intercepts, the y-intercepts, and the domain, because those are all going to be parts of what you're going to be asked on your quiz. But they are also already things that you're doing. You just don't even know you're doing it. Okay? Domain is just the opposite of the vertical asymptotes. But we'll put it all together tomorrow.